Welcome back, everybody, to the continuation of problem 7. Okay, we've already worked through parts A through D of this problem, so we're going to look at part E. And just to refresh our memory on what the problem is all about, we're given the graph of the velocity of a helicopter. Okay, so notice the units here. Feet per minute is our velocity unit, and then minutes is our time unit. And part E would like us to estimate how far the helicopter flies in the first 20 minutes of flight. Okay, so how do we do that? How do we find a distance if what we're given is a velocity graph? Okay, well, I'm going to remind you of a fact here, okay, that we can do a problem like this. I claim that the distance that we're looking for is actually the integral of this function. I'm going to give myself just a little bit more space here. Okay, so that distance that we're looking for, I claim, is the integral from 0 to 20 of the velocity function. Why is that again? Okay, well, let's think about units. When you calculate an integral graphically, what you're doing is calculating an area of some sort. Okay, so you can think of this v of t as being the height of a rectangle, and the dt as being the width of a rectangle. What are the units of both of those two measurements? Well, velocity, we can see from our function up here, is being measured in feet per minute. And time, on the horizontal axis, is being measured in minutes. What do you get if you multiply those two units together? Okay, well, the minutes cancel, and you just get feet. Okay, so that kind of confirms that this integral has the right units. We're trying to measure distance, and feet is the correct units to do that in. All right, so what it comes down to is we need to estimate that integral from 0 to 20. Our function is always positive, so that's going to be the area under the curve between 0 and 20. And there are different ways that we can estimate this, but maybe the easiest way in this case would be to think about rectangles, just to do it by drawing in some rectangles. And on this scale, I'm going to choose 4 rectangles. That's kind of a convenient number. We'll do our best just to draw in 4 middle-sum rectangles. Okay, so starting between 0 and 5, the midpoint hits our function about there. Okay, and then between 5 and 10, the middle point is maybe about there. Okay, we're just doing our best to estimate this, remember? Okay, and then we get a middle point maybe at about that point. Okay, and then finally between 15 and 20, the middle point is maybe about there. Okay, and if we can add up the area of those 4 green rectangles that I just drew in, that should give us a good estimate of the area under the curve. All right, so how do we find the area of a rectangle? Well, we take the height times the width. And so what do you notice about the width of each of those 4 rectangles? Notice that it's just 5. So for that first rectangle, we want its area. We're going to take its width and multiply it by its height. We have to estimate the height as best as we can. This is not an exact science, but if I had to take a guess, I would say the height of that first rectangle is maybe about 25. Okay, then we move on to the second rectangle. Its width is still 5, and its height is, if I had to guess, maybe about 140. Okay, you might disagree with that estimate, so there's going to be some error here. I'm just taking my best guess. Then we come to the next rectangle. Width is still 5, and the height is maybe, that looks to be about 400. Okay, and then finally the last one, same width and a height of about 490, we'll say. Okay, and then it would be a matter of just adding up those numbers and seeing what you get, and that's going to be about 5275. We already analyzed this and came to the conclusion that our units are going to be feet, and so there's our best estimate of how far that helicopter traveled.